This is our video for Pythagoras Theorem. The statement that you would see on your exam paper is prove that in a right angle triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. So that's just stating Pythagoras Theorem in words. We've got the same layout as usual: diagram, given, construction, to prove and proof. We're going to start off by drawing the diagram. So have a think, what do you think the diagram should look like? The diagram is just a regular right angle triangle, and I've named the vertices A, B and C. My next job is going to be to write down a description of this in the given section. So take a moment yourself, pause the video and see what you think the given section should actually say. So our description of the diagram is just that it's a triangle ABC where the angle ABC equals to 90. Now I need to write down what it is that I want to prove. So I want to prove that the square of the hypotenuse, which is AC squared, equals to the sum of the squares of the other two sides equals AB squared plus BC squared. So my next consideration is going to be, how am I going to edit my diagram to put in my construction? So in this case, what I'm going to do is I'm going to draw a line from B to AC that is perpendicular to AC. So that's how this will look. I'm going to mark in those right angles, and then I'm going to write a description of what I've done in the construction. I'm also just going to mark in the point D here, and I'm going to name these angles 1 and 2. Okay? So have a think, what do you think you should write in your construction? So my construction is going to be to draw a perpendicular line from B to AC, label the point D, and label the angles 1 and 2. And now we're into the proof. This proof is based on similar triangles. So I'm going to take the large triangle in turns with each of the smaller triangles that I've created and identify that they are similar. So I'm first of all going to look at the triangle ABC and the triangle ABD. And I'm going to identify the angles that are common in them. So first of all, the angle 2, well, that's in the big triangle and it's in that smaller triangle. So I'm going to say angle 2 equals to angle 2, really stating the obvious there. And that is just a common angle to both those triangles, or it's shared if you like. And I can also see that they have a right angle in common. So I've got an ADB is equal to the angle ABC, and that is because they are both 90 degrees. Now, as we've discussed before, if you've got two matching angles, well, then the third angle must match. So that implies third angle matches. So that tells me that the triangle ABC and the triangle ABD are similar. AAA. So next what I'm going to do is draw those two triangles side by side in the same orientation, so facing the same direction. So pause the video for a second, have a look at the big triangle ABC and the small triangle ABD and see if you can draw them correctly facing the same direction. So I've drawn both of my triangles, and now I'm going to use the fact that they're similar to write their sides in ratios or fractions. So in this case, I'm going to write down that AB over AD equals to AC over AB. And I'm going to manipulate that equation. So I'm going to bring up what's in the bottom and multiply it by the opposite side. And that's going to give me AB by AB equals to AC by AD. But of course, AB by AB is AB squared, so I'll write it as that. Okay, so part of the way there, I have AB squared, but I'm not all the way there yet. I still have to get AC squared and BC squared. So the next one that I'm going to try and get now is BC squared. And I'm going to get that by doing a very similar set of steps to what I just did for AB squared. The only thing I'm going to do differently is that this time I'm going to consider this triangle BDC with the bigger triangle ABC. And I'm going to go through a very similar set of steps. So I'm going to say that, well, in this case, they both share the angle 1. And that is common to both triangles. And they've still got right angles in both cases. So in this case, it's the angle BDC equals to the angle ABC. And they're both 90 degrees. And just like before, if two of the angles are matching, that implies the third angle is equal, or the third angle matches. And so this tells me then that the two triangles that I'm looking at are similar. So the triangle ABC and the triangle BDC are similar. AAA. So again, I'm going to try and draw both of those triangles now facing in the same orientation, in the same direction. So again, pause the video now and see if you can do that yourself. And see at that stage then if you can write down two pairs of fractions in the same way that I did in the last section. So I've drawn the two triangles facing the same direction, and now I'm going to make my fractions. So I'm going to say that BC over DC equals AC over BC. So BC over DC equals AC over BC. And as before, I'm going to do a bit of rearranging here. I'm going to bring the BC up and multiply, the DC up and multiply. So I'm going to have BC by BC equals to AC by DC. And again, a little bit of tidying up here. These two are obviously going to be written as BC squared equals to AC by DC. So I've got two important statements here now, AB squared and BC squared, and they're clearly part of what I'm trying to prove. And in the statement that I'm trying to prove, AB squared and BC squared are getting added together. So I'm going to do the same thing now with these two statements. So I'm stating that AB squared plus BC squared equals to AC by AD plus AC by DC. Now, ideally, I'd like to be able to tidy up what I have over here. And as you can see in my to prove statement, what I'm missing at the moment is AC squared. So can I get that out of this? Okay, well, what I'm going to do is I'm going to factorize AC out of both of these terms. So I'm going to say AB squared plus BC squared equals to AC by AD plus DC. So how am I going to get this AC squared on the right hand side? Well, if I go back up and have a look at my original diagram again, I can see that AD plus DC is actually that whole side AC. So I'm going to be able to substitute AC in for this statement here. But first I'll just make a note of that in my proof. So I've just made a note of the fact that AC equals to AD plus DC. And now that's going to allow me to replace this bracket AD plus DC here. So that's going to end up giving me AC by AC. But of course I know that AC by AC is AC squared. So now I have the statement that I required. AB squared plus BC squared equals to AC squared. And at the end then I can write QED if I like, just to show that I'm finished. And that is Pythagoras theorem proved.